Hi everybody, welcome to another General Interest Sharcnet webinar. The topic today is automating software build process using CMake Part 2. My name is Armin Sopani and I am with Sharcnet based on University of Ontario Institute of Technology. And this is my email here, so if there is a question in your mind after this talk is over, you can contact me directly. So in part 1 of this seminar, we introduced CMake and the first 3 steps of our tutorial. If you want to access the slides, you can find them here at this link in the Sharcnet channel in YouTube. And this is the site actually, but the same link here. And the whole tutorial for this part 2, you can find them at the link, this link, tutorial files at Sharcnet's GitLab instance. So this is the link here. If you check and go to this link, here is the whole tutorial. We have 10 steps that I'm going to hopefully cover most of them if we have time. And if you want to have it on your computer, you can just copy this link to your clipboard, and then on your command terminal, you can then have Git Clone and then paste this link to have your tutorials. But I start with nothing here. Just I try to produce all the files here one by one, so you can see how you can make all the things like this. Okay. At first, we have. Let me show you the content of all the steps that we are going to cover. We actually covered first 3 steps in here. Let me show you. First 3 steps in first webinar. But I'm going to have them and produce these files quickly again here because we just build on previous steps. So I quickly go over these steps and then we continue. First, we have a minimalistic make with 2 lines of CMake script. We make a file and build a simple hello world example. Then we add parallel MPI version and and we use find package feature of CMake to find the MPI libraries in the Sharcnet or any other systems. And then we try to building both serial and parallel MPI versions. Then we cover the having options using the option command in CMake. We make the MPI version optional, and then we try to show program version using the boost program options. The whole point of this step is to learn how to find complex packages like boost, and what is the best or efficient way of using find package for a library or package like boost. In step 6, we reading version info from the configuring header files, and we learn how we can do that in CMake to read the version numbers from a file that CMake produces from a template. In step 7, we learn how to installing files using the install, and then in step 8, we learn how to do it correctly in Sharcnet environment, which uses the module environments. Because if we don't use RPaths and some measures that CMake has for that, In Sharcnet environment, it can't find the libraries when dynamic link libraries when it tries to run, when you try to run the program. Then in step 9, we make installer packages. We make, for example, RBM or Debian packages for our code. And also under the Windows, we learn how to produce the installer packages using the NSys or nullsoft installer script. At the end, we learn how we can use some test cases to our build. Okay, let's first try to have our first step directory, and I copy the initial, or we can also, because it's really, we don't have anything here at first, we try to use the VI or any editor to have our hello CPP program here. Our code is really simple. It's just hello world, prints hello world on the command line. So I just put this. The script, CMake script, to make the whole program compiled and linked is only 2 lines of code. So we can, the only thing that we should do is to add a file called CMake Lists.txt in the same folder, and then put only 2 lines of code. That's it. So the first line is project, the name of the project, project hello, and then we add one executable file named hello, which is built using the source file hello.cpp. So we can save it, and then here let me check. Maybe I had a problem here. I just, okay. That's it. Okay. Now we can ready to have our files. As we mentioned in the previous tutorial, it's best to have out of the source builds when you use CMake. So it's better to have a separate, make a separate directory named build, which is usually used under this name, and then going to that directory. And here we can use CMake dot to refer to the previous folder. Here CMake can find the CMake list.txt and produces the make files. I use the Ncursors version for this one, or maybe just use the GUI version because we covered it in previous tutorial or webinar. Okay, using this way, let me put this window here. The only thing that we need to do here is to, actually this one is running on the Sharcnet cluster system Orca, but because we have, I use the mobile extern, it uses the X11 forwarding, so we can have GUIs like this in my system. So I first click on configure and generate the Unix make files. And if everything is okay, it tries to locate the Intel available C++ compiler, which is in this case is Intel, and then we can generate the file. And now we are ready to make our program. If I use make help here, it shows all available things that I can do. And if I don't give any argument, it by default it uses the make all. So if I just put make here, it just builds the program and puts the source code in the same directory here, which is hello, and I can run it. So this one is the first step. Let's go to step 2 here, which we want to have the MPI version of the same code. Now I can use the VI editor again to have hello MPI hello CPP. This is the MPI version. And the MPI version is more complicated than that, but it's just a C or C++ code. Oops. Okay, there is a feature in V or VI editor that when you have something like curly brace, it tries to put or the comments, it adds other ones as a comment. So it's better in this case, I just use the Nano Editor to prevent this one from happening. So I use the Nano Editor here for MPI hello.cpp and paste it here. Okay. And save it. Now we have our MPI hello, but we can copy the previous step CMake lists. Sorry. CMake. What's going on here? Let me see. Oh, sorry. I forgot to. Let me move a step 2 to our previous folder. Okay, now we have a step 2. And now we can copy a step 1 CMake to this folder. Okay. The only thing that we should change here is actually first we should change our first line to say CMake minimum required version, because when we are going to use the find package facility of CMake, it needs the version, so to check whether this version supports the needed package. And the next thing that we should add here is, instead of this line, we use the find package MPI. It tries to find the package MPI, and if it's a MPI package or MPI library is there, it makes the MPI found variable to true. So we can check it, and when that happens, we can include directories for the header files using the include directories command of CMake, and then we use the add executable same command, but here we use the MPI hello CPP as the source code, and the binary would be MPI hello. But here we should also link with the MPI libraries, which when the MPI find package MPI successfully found the MPI, here this variable sets to the directory of that. So as we said in the previous webinar, in CMake, when we want to dereference a variable, we use the dollar curly braces to dereference the value, so having the correct path to the libraries. And then we end if this. That's it. And if now we use the make GUI, oh, sorry. First we should make build directory, cd to build, and then CMake GUI like this. And the same sequence, configure, and then generating the scripts and quitting the whole thing. And then we should have make to have our MPI build. But here, because the MPI hello is parallel version, when we want to run that, we should use the MPI Run command for doing that. But when you want to do this kind of run, it's better to not using the login node, but the development node. So we can SSH to org dev1, for example. Let's see what's the status. Okay, it's almost free. And then we can go to the directory that we were working. And step 2 and build. And now I can use the MPI Run -N4 to run the MPI hello example. So the output is more or less the same, but we have also the rank number and the processor in the rank number for the 4 processors that we use. That's it. But usually this is the case that for a program you want both MPI and serial version of the code. So if you want to do that, in a step 3, as we can see here, we want to build the both serial and parallel versions together. So we can make the step 3 folder, changing to that, and I can copy the previous ones. For example, we can start with the CMake from previous step. Step 2, CMake Lists. And also, we can have both MPI hello CPP from step 2, and from step 1, we can have our hello CPP. That's all the things that we need now. Okay, the only change that we should do to our CMake list is if I do like this, or it's better to use vim diff to have both versions. So I can show a step. Actually, yes, let me do it like this. It's much better. A step 2 CMake and current CMake, which at the first are the same. So the only thing that we should add here is, let me switch to this version because this one is our current version, and we can add executable here for the hello version. Let me put it here. Since that my okay, let's delete these lines. So the only difference is that we have the add executable for hello CPP here. So it's gonna make both versions, both MPI hello and hello, and that's it. Now I can save this version and then quit the other one. And if I make build and see the build, the same sequence of commands. This time, let me use the N-curses version of CMake. You can just use the CMake like this to in console or terminal environments. It's a little bit faster. Okay. And it shows that it's found the MPI version here correctly for C and C++. And then we can make. But this time, because we have two programs to build, we can use the parallel build using -J. And because we have two programs, 2. So it builds both at the same time, which is much quicker here. And now we have both hello and MPI hello, which we can run using the MPI Run. Now let's go to next step, which is the step 4. Sometimes it's usually the case that when you have a program which has both serial and parallel version, you don't always want to build the parallel version. So that's a good idea to make the parallel version or MPI version as an option. So when there is no such a library, you can build the serial version on your computer. If we want to do that, it's really simple in CMake. We just make another folder for our step 4, and then go to step 4 here. So we can copy all the files from the previous step, which is step 3. Oh, sorry, wrong command. Okay. This is a good thing because when we have the build version, out of source build feature of the CMake, it's good that in this kind of situations, we have only one folder, additional folder, which is built, which is not going to be included in this kind of copies. And there is one other thing that is worth mentioning, which is if you use a version control system like Git, usually it's good to have your .git ignore file. And if you use CMake, the only thing that you should add to your .git ignore file, in this case, for example, in this folder, and you can find this .git ignore file in the repository, the GitLab version for the tutorial. The only thing that you should put in this git ignore file is just build. So if you put build here, it's not going to include the build folder when you try to git add something. So that's the only thing that you should put when you work with CMake, and that's it. But maybe there are other files too, but for most cases, just putting build in the .git ignore file will do the trick. So in step 4, now, let's use the same vim diff trick here, but this time we use the step 3, and okay, let's go to this one. And the only thing that we should add here to make it optional is two lines of code. First, we add a command option and named it build MPI. So this variable, when the user answers yes or check the tick mark on that, it asks whether build MPI version, and by default we put it on. If we want to make it by default off, we can change this on to off. And then we check for the build MPI variable. If it is true, then we try to find package MPI, and then we build that. So it would be like this. But we can also indent these guys like this. And we need another end if here. Then we can save our file. So this time, if we use the make build and then cd to build, and use the I don't know what happens to my, okay, because it's, let me exit, because I didn't mention the -y when connecting to the development node. No problem. Go to a step 4, build again. And now we can use the CMake GUI to have our build. So when we configure here, we will have an option. I uncheck the grouped and advanced one so we can see the build MPI here. So if the check mark is here, it's going to build the MPI. And because we put it on by default, it's going to be on. But if we disable or uncheck this one, it's going to build only the serial version. So by having this checked and generating the whole thing, we can have both serial and parallel. And if we want to only make the parallel version, we can say make MPI hello. So in this way, you just make the parallel version. But let's go to next step, step 5, which usually maybe for your program you need some complicated packages like Boost, especially when you use C++. And for these kind of packages, the whole process is a little bit tricky. So for this step, let's add a feature to our program to print a version and help information for the program hello using the Boost program options. Boost program options is really powerful, and it's like using the shotgun to kill the fly for this case. But because we are going to demonstrate how we can find a library with also linking necessities, that's a good case scenario. So here we make our step 5 directory and change to that. And we can copy from previous steps, step 4 here. But we need more files for this case. Here, we should both change the hello CPP and MPI hello CPP. So let me do that. It's a little bit more coding here involved because we are using the Boost program options to do the whole trick. But let's do it now. We just first start with hello CPP. Here, we just need to remove this guy. Let me to save some time, maybe it's better to have our code copy and paste because there are lots of. So let me just let me use the Nano version to prevent this from. Okay, that's it. And now we can paste it here. The whole code for program options is like this. Now it checks the for two switch or options, help and version, and if it finds there, it tries to print the version number and also the information like this. So this is the version for hello CPP, and for MPI hello is the same one, but I just go to CMake Lists here. In CMake Lists, the thing that we should add here are first before this line, add executable, we try to find the boost package. So by this, it's more or less like find package MPI, but because the boost is more complicated and it has version, we can specify the minimum boost version that we need, and also we say that it's a required feature, so if CMake couldn't find it, it stops. And because there are several numbers of libraries in Boost, we can select the one that we want, which is program options here. So by having this one, after finding the Boost, we can include directories, Boost include doers like this. But for each executive or executable program, we should also link the library, because most of the Boost libraries are header only. But this specific case, which is program options, is a linkable file. So you should also link the file. In order to do that, we should add another line of code here after add executable here, which is target link libraries, and we link Boost libraries to hello. But we should do the same thing for the MPI version 2. So we add this line also, the same like this one here too. So this one is for MPI hello. And that's the way it works for this one. So the codes that we need are like this, but sorry, we should actually only add this one, because we just need the MPI libraries to be added like this. And then we can save our code and try to build that. If you use the same procedure here, we can now try to generate the toolchain files. But here it's gonna complain. Why? Because the version, Boost version, that is by default in CentOS operating system is 1.41. But we need, we specified that the minimum version is 1.55. For this case, is no matter, but that's, I just wanted to demonstrate this. So in order to have this fixed, we should module load the Boost version that we need here, at least the one. So if I put module load module, let's avail Boost, we can see that for the Intel 12 version, which is the default compiler, we have both Boost 1.53 and Boost 1.55. So I should do module load Boost Intel 12 and 1.5, and now if I do the same thing, oh, okay, because we change the cache, it's better to get rid of the previous cache too and have it from the scratch. So here we try to configure again and generate the whole code. Okay, no problem. Boost 155 found, and then we can read this and then have a, sorry, we are not on, oops. Oh, I forgot to generate to save the generated configure file. So now we are ready to go, and we can put make to have both versions. And now if we put hello -v, it puts the hello version, or if you put -h, it shows the usage. And it's the same for MPI hello too, because they are the same. But the code is a little bit different. You can find the code for the MPI hello. It's you should just put the things over there. So for the next step, which is reading version info from one place. That's a really good trick, because usually when you want to have version information, there should be one place that you change the version of the program, and it should be reflected in all the source codes. And CMake can do the trick for you too. So in this version, in this step 6, I try just to have the same thing, but rather than hard coding the version number in C++ code, we try to make CMake get it from a template. So if we have the file from the previous version, let me cp from step 5 to here. Okay. And there should be also one file. Let me copy the MPI hello from another version of. Oh. Let me get it from, because I didn't change the MPI hello for the previous version. Let me get it from the source here, from the repository that I have. So if I put MPI hello CPP, yes, it's complete. Now we can continue first with CMake. In CMake, the changes that we should do is let me do vim diff again, maybe better. Step 5, CMake list, and CMake list from here. So here, the thing that we should have first, after the project line, we put the code to get the version from a file. Here, the color coding is not good here. You can see maybe the lines. This one is 1 and 0. But here, we have two variables, hello version major and minor, set it, and then we use the configure file, CMake, here, to read the source file and replace it with these versions. And when we've done that, it actually doesn't show the color coding here is not good. Maybe it's better for me to use the non-diff version. I don't know why the color coding is Orca is like this, but usually it should be here. I can't see that. Maybe a artifact. But after doing that, we should also include directories for this line. So this is the line we need to include the CMake current binary directory. So when the generated file is there, CMake can read that from that file. That's all that you should do to your CMake file. And we need also another file here, which is called version hpp.in, which is the template file here. So we put these two lines there. These two lines says that can get the version from the CMake script and replace these two variables with the actual values. We should also modify our CMake files, CPP files, to have this read these versions from version.hpp file. So in this case, I need to add include version HPP here, and then here, rather than using the hard-coded values, I use the ones that are in the file. So here, I just put them like this, and okay. So rather than having the hard-coded version, we get the versions from the from our file, which is the version.hpp. So this time, if I make the build tree and see the build and CMake like this, it's going to build both versions, but using the configuration files. And the good thing here is that after having this, we can make the installation packages using the same variables. So the next step that is really important is to install the files to the place that we need them. Here, for doing that, during the step next step, which is the step 7, We try to do that, but because we are out of time, I just changed to a version that I have cloned from the tutorials, so I can quickly show you how you can do these things. This one is actually mine. Let me go to CMake tutorial, that is. So in a step 7, we want to install the file. So let me show you the difference between this version and the previous version, which is a step 6, CMake, and this CMake list. Oops. Vim diff. Okay. If you check this, we only need to add 2 lines here. One here after the add executable, which is install. After we have the executable, we can install the file to the place that we want. Here we just specify the hello, the name of the target, and the destination, which will be in the bin directory. And this is the binary file that we need. We do the same thing here for the MPI version, but using the different name. Now, if we do the CMake, do the build, make the build directory, and oops, CMake GUI. Here, if we configure the package, after the configuration completes, we see a variable here, CMake install prefix, which by default is USR local. If we want to have to produce the RPM package, it's better to have this not changing this one. But in our case, if we want to just copy it to bin directory, our home directory bin, we just use our home username at Sharcnet and enter this and try to configure and generate again. Now, if I do make help, I can see that there is another option named install. So I can both build and install those codes. So if I do make install, it tries to build both binaries and then installing them into my home bin. So as you can see here, it's installed in my home ASOP Honey bin, both programs. But there is one thing missing here. If I run hello in current directory, it works. But the one that is copied, that was copied in my home bin, I can run it using the hello. But if I try that, it complains because it couldn't find the shared libraries. If I do LDD to see what's wrong, for hello, it shows that the libboost not found because it was part of the module and it can't find that because the RPadders are removed by the CMake. The only trick that we should do to remedy this problem is in a step, the next step, which is a step 8. We only need to add just one line to our CMake file to make it work in Sharcnet environment or any environment that you use the module system. So here, just by adding this line, it fixes the problem. Set CMake install rpath use link path to true. So if I do the same thing here, have the build, and then the build, we use CMake GUI to build the thing, configure, and then generate. Here I change it again to my home directory, and then configure and generate. If I make install J2, now the problem is fixed. As you can see, the set runtime path is now correctly linked to our program. So if I use the LDD for home in hello, now the linking is correct, and if I do hello, it works. And the next two steps that I'm going to cover really quickly, in step 9, we try to make the installation packages. So here, the only thing that we need to add to our script to make installation packages is 3 lines of codes. Include install requirement system libraries, and then setting the versions using the versions that we already have, and then including the CPAC. If we add these 4 lines of code, and optionally, which is in this commented out line, we can have a license to be shown when we want to do that. So if we try to build this version now, when we configure and generate the toolchain files, here, if we group the things, there will be one more option, which is CPAC. If I open CPAC, I decide which binary versions and packages we need. Because we are in our Sharcnet environment, we are on CentOS. RPMs are the good ones in this case. So we can uncheck the other ones, for example, Debian or others. But TZ and TGZ are also good. So if we try the RPM, checked, and generating the configure and generate. Now, if I make help, you can see there is an option for package and package source. So if I do make package, let me package, it tries to build the packages too. So here we have the RPM and GZ and Z packages. So if I do, for example, RPM X RPM. Maybe I just put it wrongly. We can see the thing. So the RPM package is there. And the last step, which you can find it in our Sharcnet GitLab, tries to have some test cases. It's only just 3 lines of code at the end of the CMake that if you add to your program, you can do the test. There is one macro and also do test to test the output of your program. So using that feature, you can also make your, if you add the C-test package, then you can also have the continuous integration thing. If you do that after building the CMake the toolchain file, do the CMake help to see other options that is available using this one. I think that brings us to the end of this webinar. Thank you for your time. If there is any question, I'll be more than glad to answer that.